Okay, so let's get started. Hopefully you're on day 5 right now of your notes. You should have plenty of time here to start the assignment, we'll see. Okay, so here we go right away with the first theorem. Look at what I have given you right now. A is parallel to B and B is parallel to C. So you know basically all 3 lines are parallel to each other. But we got to explain why A is parallel to C. When you read that, I know a lot of you probably have the tendency to say, oh, it's substitution, substitution, substitution. Again, I'm trying to drive this home. Substitution can only happen when 2 things are equal to each other. Are A and B or A and C equal to each other? No, this is not substitution. I can only do substitution when they're equal to each other, not parallel to each other. So we're going to write this down 3 times in the proof, in the theorem, and then I'll tell you what I need on your index cards right now. So because A is parallel to B and B is parallel to C, yes, A is parallel to C now, but why? Here we go, and I'm going to have you guys start coming up with it on your own. Here we go. Oh, just definitely left there. Okay, here we go. Who's got 9? 9? Okay, here we go, Justin. We're A. What do you know about A in the givens? And what do you know about C? So you're telling me A and C are both parallel to? The same line. Everyone agree? Okay, so there's our theorem. A line, 2 lines, 2 lines, which in this case would be A and C. 2 lines parallel to, Justin, what are they both? What are A and C both parallel to? B, the same line. 2 lines parallel to the same line are, and then someone's going to finish it now, 2 lines, A and C, parallel to the same line, B, are parallel to, 10? How do you think I finished this? 2 lines parallel to the same line are, there we go, parallel to each other. And there is your first theorem for today. Not substitution. So we can write, here's the new theorem, 2 lines parallel to the same line are parallel to each other. Now on your index card, here's what I want. On the front, and whatever, I don't care, whatever you call it, the front, doesn't matter. On the front is going to go your givens, A parallel to B and B parallel to C. That should go on one side of your index card right now if A is parallel to B and B is parallel to C. So as you look at these and study these, this is what you're going to be looking at. This is what you're going to be given. And then you could flip it over to the back. And hopefully by Monday now you can tell me that conclusion, A parallel to C on the back, along with the theorem Y. Okay, so on the back of your index card, A parallel to C, along with 2 lines perpendicular to the same line are parallel to each other. Okay, so the givens on the front, conclusion and theorem on the back. Anything on how that one works? We're going to go from the easiest to the toughest here. Everyone all right? Now what we're going to do on the next, or right at the bottom, it looks like on your packet. Now what if I change those parallel signs to perpendicular? Okay, what if 2 lines are perpendicular to the same line now? So let's talk about that. Instead of just giving you the theorem, I want you guys to figure it out on your own. So we're going to do a proof right now that shows the theorem. So everybody see M perpendicular to T and N perpendicular to T. I need to somehow prove M and N are not perpendicular, but are parallel to each other. And you're going to help me out doing that. I wrote in all the statements for you. You're going to help me out with the reasons. Okay, so I know M and T are perpendicular, N and T are perpendicular. So look at your diagram right now. Look where M and T meet. And look where n and t meet. Those are perpendicular to each other. So why are 1 and 2 right angles then? How do I know 1 and 2 are right angles? What told me that? Who's got 7? Thank you very much, Amy. Perpendicular lines form right angles. Yep. Okay, now why are 1 and 2 congruent now? Now that we know that, why are 1 and 2 congruent then? Ted?
1 and 2 are congruent because right angles are congruent.
All right angles are congruent. Perfect. You didn't fall in the trap. Good job, Luke. And I'm not going to discuss the trap either. Okay, now why is m parallel to n? Remember, we are in the parallel lines unit, and you just said 1 was congruent to 2. Look at those angles right now. Why would the lines be parallel then? Right, it's the unit we're in right now, parallel lines. So tell me why here. 7. Not only are 1 and 2 right angles, they're also corresponding. And if they're congruent, I have parallel lines. So corresponding angles congruent means I have, yep, parallel lines. So do I need to do this proof every time? No, you've just discovered the theorem, which says, here we go. Help me out with this theorem. 20. Okay, ready? I'm not going to let you just go on your own there. Don't worry. Okay. I needed m and n. Tell me something from the givens about angle m. From the givens, what did we know about line m? And what did we know about line n? So what you're telling me is 2 lines perpendicular to the same line are, what did we conclude about them at the end of our proof here? Those 2 lines are not perpendicular, they are parallel to each other. Okay, so 2 lines perpendicular to the same line are parallel to each other. Okay, that's what you guys just proved. So now this proof we just did is 2 steps now instead of 4. 2 steps. Okay, so when you get the theorem written down, go ahead, go back to your index card. Givens on the front, conclusion and theorem on the back. Okay, just a review before I get into this last one. Just a review. When can I use this first theorem? If I have 2 lines. If I have 2 lines parallel to the same line, and this last theorem we just went over is 2 lines perpendicular to the same line. Okay, so it matters if it's parallel or perpendicular to the same line. Now I'm going to change it up. This third one's probably the toughest to understand because it involves both perpendicular and parallel lines. I think it would add more confusion to it if I had you do this proof. So just keep the givens there in the proof statement, but we're not going to do the proof that leads to the conclusion. Okay, here we go. I'm going to turn it over to you guys now to help me out here. Who's got 6? Who? Okay, here we go, Nick. I'm going to look at my proof statement. M perpendicular to T. Let's go up to the givens. Tell me what you know about line T. Everyone agrees it's perpendicular to N. And N is also part of a what? It's also part of a parallel line. Does everyone see that? T is perpendicular to one of two parallel lines. Everyone see that? Okay, so that's how we're going to start off this theorem. A line perpendicular to what's T perpendicular to again, Nick? N, and what do you know about N? Okay, a line perpendicular to one of two, what type of lines? Parallel lines. So does everybody see I have that right now? I have line T that's perpendicular to one of two parallel lines. Does everyone see that I have that? Okay, then what do I know then? A line perpendicular to one of two parallel lines is also T is also perpendicular to M. How can I describe what M is? It's the other parallel line. Everyone see that? M is the other parallel line up here. So again, a line perpendicular to one of two parallel lines is also perpendicular to the other parallel line. It's wordy. That's why it's so hard to understand. It's so wordy. So hey, before you write it down, take a look up here. Let me put lines to these now. Ready? A line, that was T, perpendicular one of two what line was T perpendicular to? N, which is one of two parallel lines, is also perpendicular to the other line, which was what? M. So just putting names to this right now. Okay. So go right ahead and go to your index card. Okay, so here we go. Get those three out in front of you right now that you can see them. Get those three theorems out right in front of you, because now we're going to try out two proofs where I may need them. Okay, here we go. I'll give you guys a second to mark, set up anything you want there in the first proof. Before we talk, what can I use? See what we can do now. Who's helping me out? Who has 10? Okay. So what I need you to do right now, Luke, is pick two right now that you could think you can use one of those three theorems on. Because there's a couple ways you could go here.
Well, what I thought you had to do is get C parallel to A.
Okay. Okay, hold on. Hold that thought right there. Don't say you're on the right track. So which two are you using right now? That's what I want to know.
The parallel lines.
Okay, and which two givens are you using? Because you have three different givens up here.
Yes.
Which two are you applying that theorem to?
The first. The first two.
So here you go. You're using A perpendicular to S and C perpendicular to S.
Yes.
Okay, that's all I need to know. That's the two we're going to use right now. So we're saying A perpendicular to S, C perpendicular to S. Which theorem can I apply now? Here we go. One. A is perpendicular to S and C. So what do I know about A and C right now in those givens? They're both perpendicular to the same line. What's the theorem say? If I have two lines perpendicular to the same line, they are parallel to each other. So A is parallel to C. Everyone all right how we got that out? What's the theorem say? Two lines. Ooh, not parallel. I didn't have two lines parallel to the same line. I had A and C were both perpendicular to the same line. So two lines perpendicular to the same line are parallel to each other. Everyone okay on how I got A and C now? All right, I got to get to C and B somehow. Use all the darn givens. All right, Luke just used A perpendicular to S and C perpendicular to S. There's one more that we have not used up there. We need to use it. It's given there. 10. No, never mind. You're good. You've answered enough. 14. Okay, which one have we not used yet, Heaven? Okay, so I know A is parallel to B, and you just wrote down the true statements. A is parallel to C. So C and B are both parallel to the same line. So I should know what about B and C then? They're parallel to each other. And that's the first theorem we went over, which says two lines. Oh, go ahead. There you go. Which is what we needed to prove. Questions? Something I need to do a better job of is challenging you more, and that's what I'm going to do right here. We are not going on to the next proof. All right, I want you to help me to do this proof a different way. Instead of starting off with A parallel to C, we could have started off a different way. Okay? Luke took those first two. Absolutely correct. All right? Do you see any other repetition of lines in other than these first two here? Emma, go ahead. What I would like you guys to look at now are those first two givens, first and third givens. A perpendicular to S and A parallel to B. Third theorem, and we're not going to write it all out, but I want to show you here. Ready? I got A perpendicular to S and A perpendicular to B. So isn't S perpendicular to A? I know it's perpendicular to A, but what is A? A is part of A? Parallel line. Look at that theorem right now. Look at that theorem. So if I have a line perpendicular to one or two parallel lines, what should I conclude from this? Oh, what should I conclude from this? Instead of A parallel to C, I could have also concluded what now? Who's got one? Well, I'm not involving C at all, so don't say C. This is A perpendicular to S, A parallel to B. Ready? Go. Got your theorem, that third theorem we went over. Ready? Hey, a line perpendicular to one or two parallel lines is also. Okay, where's your third theorem in front of you right now? The third one we went over that involves parallel. That's not the third one. That's the second one. We went over one that involves perpendicular and parallel lines. Ready? Okay. I need you to read it. Okay. I want you to use it to tell me the conclusion now. Ready? S is perpendicular to A, which is part of a parallel line. So what does your theorem say? A line perpendicular to one or two parallel lines is? So you tell me S is not only perpendicular to A, but it also should be perpendicular to the other parallel line, which is what up here? So I could have also wrote what? S is? Okay, that's the other way I could have started this out. By saying S is perpendicular to B by that last theorem I showed you guys. Amy. The other parallel line. Why did I write perpendicular? Now, from here, take a look. You just use those givens. Now take a look. C perpendicular to S, S perpendicular to B. Take a look, because I'm going to ask somebody here. C perpendicular to S, S perpendicular to B. What can you get out from those two, and what theorem did you use? 7? Okay, we just got this alternative statement instead. So we know S is perpendicular to B, and we also know C is perpendicular to S. What do you know about C and B here? Why?
Because two lines parallel to the same line are parallel.
Are those two parallel? Yeah, I did. They're parallel, but not by the reason you used. You said two lines parallel to... Does everyone see that? Two lines, B and C, perpendicular to the same line or parallel. So I could have got C and B parallel that way. Everyone see the alternative way? Okay, I could have started out a little bit differently and still gotten there. All right. This last one, what if you can't use one of the theorems right away? All right, so go ahead, jot everything you need down, and we'll discuss. You can't use one of the theorems right now. Before I ask anybody, take a look. Do you see why none of the theorems we went over today apply? You only have one pair of perpendicular lines. You need at least two, or you need a perpendicular and a parallel set. All right. I only have one up there. So does everyone see? Don't try to apply the theorems. Nothing's going to work yet. Okay, so I do have another given, though, 1 congruent to 2. I'm hoping most of us, anyway, can do something with that. If 1 is congruent to 2, you should be able to produce a conclusion right now for me. If 1 and 2 are congruent. We are in this parallel line unit, so 1 congruent to 2 means, what do we got, 12? Okay, here's angle 1, here's angle 2. Looks like they have a common transversal here. What type of angles are they, Emma? And they're congruent, which now makes what? Which lines? There you go. Does everyone see 1 and 2 are alternate interior? And they're congruent, which is even better, because that makes the lines parallel. What do we usually write there, then? More from you guys. What do I usually write? Here we go. 19. What do we usually write? Alternate what? Is that it? You didn't prove to me what we wrote down, right? There we go. Now, take a look at the given we have not used yet. AD perpendicular to CD. I'm just going to, just so we don't get DA. Everyone okay if I rewrite it as AD? It's the same line segment. Okay, need some help. Here we go, 4. Okay, hold on, Rachel. Here we go. Notice you got a perpendicular and a parallel line going. So you know the only theorem I could probably use is that last one, because that's the only one that involves parallel and perpendicular, right? Okay, so take a look. Do you see any repetition between the two? What line segment repeats here? AD, ready? ACD is perpendicular to, and what do you know about AD down here? It's one of two parallel lines. So not only is CD perpendicular to AD, which is one of two parallel lines, it should be also perpendicular to CB, which is what I needed to prove. Okay, we're still not figuring out that theorem back there?
I think I wrote them wrong. Because mine are like really messed up. I'll do them.
Here you go. Ready? CD is perpendicular to one of two. What do I know about AD? CD is perpendicular to one of two parallel lines, meaning it's also perpendicular to the other line, other parallel line, CB. So that's how I end up with BC being perpendicular to CD, a line perpendicular to one of two parallel lines is also perpendicular to the other parallel line. Yes?
Did you say that since angle, like the other angle, CD is on the same side?
CD is not an angle.
Oh, okay. I was gonna say that they're on the same side as like angle, the two perpendicular lines.
Where are we? Because all I know is all I'm looking at is AD and CD, so the only right angle I could put is right there.
Yeah, I was just gonna say that since they're on the same, you can say the same side.
Which angles are same side?
It would be like angles. I don't know if you can call it angle C, like right next to it's the same side. So there's something.
This one right here?
Yeah, but does it not form an angle?
So you're talking about this angle C right now.
It's like the same.
So which angles are you saying? Angle C and?
The angle D.
So ADC?
Yeah.
So if you're talking about those two right there, let me highlight them. I would need to know, let's see, BC and AD are parallel, which they are. With that, so how do you know that's a right angle?
Because they're supplementary to each other, same side.
Okay. So I'm still listening how you're going to get them perpendicular.
180 minus 90 is 90.
Okay.
So you could say 90 degrees is right angle, which is 4 by 2 perpendicular lines.
If you wanted to add in those 3 to 4 extra steps, that's fine. Okay, that's fine. Other questions? Okay, before you get going on the homework, let me help you out real quick. Please go to number 3 on your homework. Okay, I'm asking you to prove FDE is a right triangle, and that's something different for us. We've never seen that in the proof statement before, which is fine. But I gave you a little hint. What do all right triangles have? A right angle. So ready? You need to first tell me that FED is a right angle, and the only way a right angle is going to be formed is if these lines are, which is where we got to today. Okay, so you need to show me that these lines are perpendicular, then you have a right angle. Then people are already asking me, well, what do I write at the end to say it has, or let's say it's a right triangle? Your reason would be right triangles have right angles. That's fine for your last reason. Okay? And finally, number 5, you guys just get thinking in the mode whatever we did in class has to be used on every homework problem, and that's not the case here. Take a look at the parallel lines I've given you. You think you're going to use that parallel line index card. Are any 2 lines parallel to the same line there? Take a look through the givens. Are any 2 lines parallel to the same line? No. So you're not going to use any of those index card theorems. This is going to be a straight review proof. All right, and I can tell you it's not 2 steps. Okay, it's not going to be 2 steps. All right, but again, you're not going to use any of those theorems. So go ahead and get going. If you get stuck, call me over. I highly advise